All right, so we're going to talk about the measures of central tendency and measures of spread, and we're going to kind of jump back and forth between this and talking about how you describe a distribution because they kind of relate together. So measures of central tendency are your mean, median, mode. They measure essentially where the center of the data is. And when you would use each of these kind of depends on what your data is like and I guess what you want to measure. The word average is very misleading. It can refer to any of these. So mean, median, mode are better. Median is, you should be somewhat familiar with these already. Median is the middle number of the data, right? It splits your data in half. The mode is the average. It's what most people say is the average. The formula for this, you do have a formula sheet, which I need to upload to Canvas, so hopefully I'll remember to do that. The symbol for it normally is X bar. That's the symbol for a sample, for a statistic mean. The symbol for a parameter mean, for a population mean, is mu. The Greek letter mu looks like a cursive U. Those both refer to the mean. You'll see a formula that looks like this. That means that how you find the mean is you take the sum of all your data values and you divide by n, which is how many they are. So this is the sum, and then n is how many there are. It's your sample size, basically, is n. All right, so that's how you find the mean. I mean, you add them all up and you divide by how many there are. Okay, so this is your population mean. And typically we can't calculate that. We're trying to estimate it by using a sample mean. All right, I want you to be familiar with both of those notations. The mode is the most frequent. We typically are not going to use that one, but it is the most frequent answer or the most frequent data point. All right, so we've got a couple of kind of little examples here to work through. So suppose we are interested in the number of lollipops that are bought at a certain store. Sample of 5 customers buys the following number of lollipops. Find the median. So to find the median, if you're finding it by hand, I mean, you could type these into the calculator, but why? That's such a small data set. If you're finding them by hand, you have to count to the middle, and they have to be in numerical order, your data does. So if these were all mixed up, you'd have to put it in numerical order first. So we just count to the middle. So that's why I said on a stem and leaf plot, it's always good to have them in numerical order because it helps you find the median easier. So the median is 4. All right, suppose we have a sample of 6 customers that buy the following number of lollipops. The median is, so if we do the same thing, go to the middle, these are already in numerical order. We have 2 middle numbers. So if you do not have an odd number of data points, if you have an even number of data points, you average them. You find the mean of the 2 middle numbers. So you're going to take 4 plus 6 and divide it by 2, which is 5. So your median there would be 5. If we find the mean of this data, I'm not going to show you that. Just add them up, divide by how many there are. That's 5.8. All right, and so now it says, let's take this sample and let's say that last person that bought 12 lollipops actually buys 20. All right, so we make that last person be quite a bit higher than it was. So what happens to the mean and median? Well, the median, all right, your middle numbers, if you count to the middle, your middle numbers are still 4 and 6. So your median is still going to be 5. Your mean, though, if you add them up and divide by how many there are, your mean is going to be 7.2. And if we make that last person buy 50 lollipops, your median is still going to be 5, but your mean is going to be now 12.2. So that brings us to an important point about the mean and the median. Resistant is where the measure you're talking about, it just doesn't have to be median and mean. The measure doesn't change if you change one data point, typically. I mean, depending on the data point you change, the median may change, but it may not change as much as the mean did here in this example. And this is speaking specifically to outliers, really. Not so much to if we change that 6 to a 7 or something like that. Okay, so if you have an outlier, the mean is going to change a lot more than the median does. So in our case, the median is resistant Presumably the mode would be as well, but we don't typically use the mode for anything. The mean is not. Okay. Before we go on, I think I want to go back to that first part where these were, and talk about some shapes of distribution, and actually talk about how you describe distributions. So over here, we're not going to define these. We're going to talk about describing the distribution. There's a little acronym that I use to help you remember what you're supposed to do, and the acronym is CUS. When a problem says to describe the distribution, you need to write a small paragraph, and that paragraph needs to include these things. It needs to talk about the center of the data, so you need to talk about either the mean or the median typically. All right, and which one you talk about depends on what we're going to talk about next. U stands for unusual. If there's an outlier or a gap, something like that. One of the S's stands for shape, and that's what we're going to talk about next. And then the last S stands for spread, and we're going to talk about that after we talk about shape. All right, so the shape of a graph has kind of two parts to it. Your graph can either be unimodal or bimodal typically, or it could be uniform. Unimodal means that it only has one peak, all right, one highest point. So a unimodal graph might be something like this, all right, versus bimodal has two peaks and maybe looks like a camel's back, all right, where it has two peaks. Uniform, I'm just going to graph these. Uniform essentially looks like a box. I mean, your distribution is not going to be perfectly one of these shapes, but uniform is essentially where like if you had a histogram, every bar would be the same height or close to the same height is uniform. Because every kind of category of the data has the same amount of data in it. Symmetric is like a bell curve. And we talk about tails. I'm not going to define that, but that's kind of the flatter parts of the graph where it's really close to the x-axis. That's symmetric, is like a bell curve. So typically symmetric distributions are unimodal. I don't know that you could, I mean, bimodal could be symmetric, I guess. But symmetric basically means you can draw a line and it's a mirror on either side of that line. But typically we think of a bell curve. Skewed, there are two types of skewed graphs. Let me make sure, yeah, I'm not skipping any. Skewed can either be skewed to the right or skewed to the left, and it depends on which way the tail is. So skewed have a big peak and then kind of a long tail. So this is skewed to the right because the tail is on the right-hand side. So the direction of the skew is about the tail, not the peak. So this would be skewed to the left. So those are the possible shapes that you might have. You want to say it's unimodal and symmetric, or it's unimodal and skewed to the right, and stuff like that. The shape is going to determine which measure of center you use and which measure of spread when we get to those. So that is the next thing we want to talk about, is which measure of center you use when. So the mean is not resistant, so it is susceptible to outliers, which means the mean is pulled in the direction of the tail. So when you have a skewed distribution, typically there are outliers. Either there's outliers on the low end if it's skewed to the left, or on the high end if it's skewed to the right. So the mean will be pulled in the direction of those outliers. So for a skewed distribution, the median will typically be here at the peak, but the mean will be somewhere over here. I mean, it might not be that drastic, but you get what I mean. For a symmetric distribution, your mean, ideally, your mean and median would be in the same place. They'd be right smack dab in the middle, because that would be halfway through the data, and your mean would also be right there. For a symmetric distribution, you should report the mean. Typically that is, I mean, think of it kind of as being more accurate. But in a symmetric distribution, really they should be the same or close to the same. In a skewed distribution, you're going to report the median because that is less susceptible to the outliers. Also, you can use that relationship between the mean and the median to predict the shape of the distribution. So if the mean and median are equal, we would say it's symmetric. And if the mean is bigger than the median, so if the mean is larger than the median, it's going to be skewed to the tail is going to be on the bigger end, so that's going to be skewed to the right. And if the mean is less than the median, that would look like this one, so it'd be skewed to the left. Okay, so then let's talk about the spread part of this. All right, that's what we have to do next. So that is your measure of spread is variability. So why is the study of variability important? Is how spread out the data is. So it tells you how spread out the data is. And why is that important? Because you want to know, is the data really spread out or is it all clustered together? Because if it's all clustered together, it's going to be basically more accurate. It's going to be better data than if it's all spread out. There are 4 measures of variability, and we'll probably, I'm just going to list these out and then I'll go ahead and stop this video because it's getting long again, and we've got a bit more to go, so unfortunately we'll have 2 videos for this section again. So the measures of variability are the range. That is the worst one. You've probably found this in middle school when you did stuff. It is the largest value minus the smallest. This is not resistant at all. All right, obviously very susceptible to outliers. The interquartile range is the next one. So quartile 3 minus quartile 2, that is resistant. So the interquartile range goes with your median, and it makes sense because they kind of are found the same way. So that is resistance. And then the next 2 kind of go together, the variance and the standard deviation. And those are, they're basically the same thing. The standard deviation is the square root of the variance. Those are very much not resistant. They are based off of the mean, how you find them. And we'll talk about how you find them in the second video.